This is an example problem to show you how to use the method of sections procedure to do a truss analysis. As we saw before, we typically like to solve the support reactions over here at RA V 3667 and over at F RFV 7333. The other thing that we like to do in truss analysis problems is to identify the angle that the diagonals make with respect to the x-axis. In this case, as before, we find that the diagonals all make 53.1 degree angles. The first thing that we want to do is to cut an imaginary section line through the members that we hope to find forces for. In this case, we draw a section line through CE, CD, and BD, and this is going to create a new free body. We can use either side, but in this case I'm going to use the left side, and basically I pull that part of the section away and that becomes my new free body. As I draw this free body, again CD is a diagonal member, so I'm going to break CD into an X and a Y component. I will then proceed by writing forces equilibrium equations. Forces in the x direction equals 0. I have three unknowns there. Notice that I show all the unknowns acting out away from the joint, which would be positive or tension. Some forces in the y direction, I solve that for CD. Now notice CD comes out to be a negative 4585 pounds. The negative means it doesn't act the way I show it, going away from the joint, but it actually acts back into the joint. As we've talked about previously, joint forces that act into the joint signify compression. Finally, I'll some moments about point C. I choose point C because it takes two of the unknown member forces or joint forces, and it'll cancel those out because they act through joint C. That only leaves me with BD and the reaction force remaining. So I solve my sum of moments equation about joint C as shown, and BD comes out to be a negative 2,750 pounds. Again, the negative means it acts opposite from the direction I have shown. Again, I show all my forces acting away from the joint, but in this case BD actually acts back in towards the joint. I'll then take the two joint forces that I found and substitute them into my first equation. That will allow me to solve for CE. CE comes out to be a positive 5,500 pounds. The positive means that CE acts in the way that I had originally assumed. I can then place these joint forces on my section as shown, again indicating which ones would be in tension, that would be CE, and which ones would be in compression, that would be BD and CD.